Welcome to Study Loop.
So we have a cycle going on 150 times per minute, and it works on 1 mole of gas, which is at 390 Kelvin. Each cycle, when this is going on, 7.5 kilowatts of work is done on the system, and 1.5 kilowatts of heat is lost by the system. Now, using first law of thermodynamics, we see delta is equal to Q minus W. By differentiating with respect to time, we have dE by dt is equal to dq by dt minus dw by dt. Now dq by dt obviously is minus 1.5 kilowatts because it is lost by the system, minus dw by dt is minus 7.5 kilowatts because it is work done on the system, giving us dE by dt is equal to 6 kilowatts. Now, the amount of time it takes for this compression, let's say, is about half the whole cycle, because the cycle is compression and expansion. So let's say half of it is compression. So that would be delta T for this compression would be half that of the time cycle. Let's call it delta T. Let's call it just T. We know that the time period of this cycle would simply be 1 by frequency. So that's 1 by 150 per minute. So that's 60 seconds divided by 300, which is 0.2 seconds. Now that we have this, we know delta E is equal to NCV dt. NCV delta T. So now differentiating by time again, dE by dt is equal to NCV delta T by delta T. And that is it. So the change in temperature corresponding to one compression would correspond to dE by dt into 1 by NCV times delta T of compression. We found dE by dt already, which was 6 kilowatts, so that's 6.0 into 10 cube watts times 1 by NC is 1 mole times CV is 5 kilocalorie per mole Kelvin. And we know that 1 kilocalorie is 4.186 joule per kilojoule, so that's there, times the time is 0.2 seconds. This gives us 57 degrees Celsius.